Thank you so much for having me here today. This is an inspired idea to bring together all the different sectors of the transportation industry. And this discussion, data, and what we can do with it is one that is both timely and I think quite interesting. So thank you very much for organizing it. I'm going to start off by taking a quick audience poll. So just by show of hands, I'd be interested in learning a little bit about the different modes of transport that brought you all of us to be here with us today. Who in the audience took a train to get here? Okay, nice. Who in the audience drove a car? Did anyone drive their own car? All right, a few. Who took a car that was driven by someone else, either taxi or some sort of rideshare service? Anyone fly here? Great. I'm going to assume, well, actually, let me ask, did anyone come on a ship or a boat? I'm going to assume not. Did anyone walk here? Oh, nice. That's great. I myself came from Washington, D.C. via London, via the Eurostar to get here. So I took a number of forms of transport. But one of the things that I think is inevitably true about today is that all these forms of transport, from walking to airplanes, have been around for many years. Some of them have been around for as long as human beings have existed. But all of those forms of transport are being transformed dramatically by the use of data and software today. So we are at a very interesting moment, and I think the question before us is what we can do, both from a business point of view, but I think importantly, since we're here in Brussels, from a policy point of view, to make sure that we are harnessing that ability to transform the future. I think it's fair to say that in the next 30 years, we will see more change in transportation technology than we have seen in hundreds of years up to this date. But the question again is what we are going to do with that. So if you think about technologies such as IoT, Internet of Things, artificial intelligence, blockchain, data analytics, all of those are already fundamentally transforming the transport system as we know it. IoT and data analytics have had already a dramatic impact. There are sensors that are on airplanes. They are inside of cars. Shipping companies, rail operators are using them to get live data on all sorts of things, including the stress levels of the engines and the energy efficiency. They're also using it to get feedback from their customers and to figure out how to make their distribution chains as efficient as possible. Those changes will in turn allow us to reduce the amount of emissions, they will reduce costs for businesses, and they will improve overall services to customers. The latest Airbus, the A350, is powered by Rolls-Royce engine. Rolls-Royce uses the Microsoft Azure platform to aggregate data, and they use that data to help reduce the fuel consumption and the efficiency of the engines at hand. But they are also using it to ensure that maintenance teams are where they need to be, when they need to be, by being able to predict beforehand when they are likely to run into problems. And I think as a frequent traveler myself, anything that helps reduce out-of-service times and maintenance times for aircraft is one I find deeply appealing. But more importantly, beyond just the improvement in quality of life to individuals, which is not insignificant, the ability to reduce costs and then to reduce the impact, the environmental impact of these forms of transport is very, very important. Artificial intelligence is another area where there's already a lot that is happening in the industry. There's driverless cars are one of the aspects of artificial intelligence that you hear about the most. It's sort of one of the areas that has captured the public's attention most immediately. But there are a lot of other areas where artificial intelligence is either will be used or is already being used today. So to give an example of that, Autodesk uses something that they call generative design, in which they use artificial intelligence to let industrial designers better design their products. Using generative design, you essentially feed parameters into a software program in terms of the cost, the materials, the purpose of what you are building, and then the software uses artificial intelligence to generate a number of designs along with their recommendations for which are the most efficient for the designers to use. that has not only increased the speed by which industrial design takes place, but it has also given the human beings that are designing them many more options to work with. And they are using those in all sorts of ways. So again, to give a practical example, one of the things that generative design was used to do recently is to rethink the partition walls in airplanes and come up with a way to design them to make them lighter in weight so that they would be as strong as they were before, but they would reduce the weight burden of the airplane in question, which again reduces the fuel cost and reduces the environmental impact of the airplane. Machine learning is a type of artificial intelligence in which the software enables ongoing refinement of the decisions that are being made by the machine, essentially learning from the patterns that it's seeing and coming up with better and better answers over time. Many types of artificial intelligence need large amounts of data in order to work. Machine learning always needs large amounts of data in order to work, and it is one of the areas of artificial intelligence which is the most interesting right now. To give, again, a practical example of how this can be, how this is already impacting transport. The City of London is a city which is, we're actually just having this discussion a few minutes ago. City of London is literally groaning under the weight of the traffic it has. It is an old and beautiful city, but it is not one that was designed to support the 21 million trips that take place inside of London each day. And those numbers are not slowing down. In fact, they are expected to increase by at least 1.5 million more over the next few years. One of the things that machine learning lets people do is to take large amounts of data and be able to analyze it and detect patterns from it that would be very difficult, if not impossible, for human beings to be able to detect on their own. So Transport for London recently held a hackathon where they used machine learning to analyze traffic around the City of London, particularly looking at the morning and the evening commutes, which tend to be two of the most congested times. And they were able, by doing that, they were able to predict where bottlenecks were going to happen and reroute human beings around those. So that had the happy impact of reducing congestion times, which again, for individuals is, I think, a significant, not just efficiency time, but major quality of life improvement, but also allowed officials in the City of London to have a better sense of where bottlenecks were going to be so they could get resources to those areas to try to alleviate the congestion. And there are a number of cities that are using data and machine learning to try to increase the efficiency of their own transportation networks. There's another great work being done in Barcelona around bicycle shares and using machine learning and artificial intelligence to try to ensure that the bicycles are being placed around the city in places where they are most needed so they can, again, be most convenient to the human beings that want to use them, but also alleviate congestion in the city overall. There's a lot of discussion about blockchain right now, what blockchain means, sometimes literally what blockchain means, but also what blockchain means for different industries. So blockchain is essentially a distributed database or ledger or record, essentially. And one of the benefits of the blockchain is that it allows a record of transactions to be kept in a way that is secure, that is verifiable, that is very efficient, and that it allows people who don't know each other and don't have any reason to trust each other to be able to create a record of events between themselves, which under normal circumstances cannot be altered and can easily be verified. So one way of thinking about the blockchain is it is a way to try to increase trust in an increasingly interconnected and digitized world. One of the places where blockchain has a lot of potential, we believe, is in the shipping industry. So today, 90% of the goods that are moved around the world are moved by shippers, but it is still a process that tends to be very paper dominant. And there are a lot of manual processes that are still exist in the industry. The the supply chain, which is a vast and complicated one, is slowed down by the complexity and by the fact that in many cases information is kept in different silos. So Maersk found that they looked at what was involved in shipping one container of flowers from Kenya to Rotterdam, and they found that shipping that one container of flowers resulted in nearly 200 different communications between 30 different organizations. Most of that on paper. That is an inefficient way to be moving goods from one place to another. There's another cost to that beyond inefficiency, which is the fact that having a highly paper-dominant system is